All right, this is our second lesson on composition, and this should be a pretty quick lesson. The goal of this lesson is to answer the question, why on earth would anyone ever do composition of functions? So the last lesson we did what composition is, we covered the notation, we covered how to do it. It's this process of plugging one function into another function to kind of come up with this like brand new combo function. And so if you've never done this before, one of the questions that might be bothering you is, why would someone do this? Who came up with this idea that you would plug one function into another function? So that is an excellent question. Thank you for asking. Why are we doing this other than it's in a math book and my math teacher said, okay, now you've got to take these functions that you probably didn't like in the first place and plug them into each other. So it's actually a great question, and it doesn't have a really, really straightforward answer. There is an answer. It's a good answer, but it takes a little thinking to kind of get around like why somebody would find it efficient to do composition of functions, or what kind of situation would you do this in. So we're going to look at an example problem with a sale where there's like two different components to the sale. Okay, and so here's our problem. A store is holding a sale on jeans. You get $10 off, so whatever price is on the sticker, you can automatically subtract $10 from it, and then another 25% off at the register. So when you get to the register, they'll take the $10 and then they'll take 25% of whatever's left. How much do you pay for jeans that were originally $90? Now, maybe like one time in my life I've had jeans that were that expensive, and I think I actually still own them, and it's been like 20 years. So, yeah, maybe you guys spend that kind of money on jeans, but I don't. Anyway, but that's what's going to work for the problem. So we got these jeans, they're originally $90, and then we're going to figure out what price do we actually pay for them. So you start with the $90, and then you take off the original 10. So you look at the sticker says $90, you say, okay, we can take $10 off of that right off. So it's $80. Now you're going to take off another 25% at the register. There's a couple of ways that you can do this. All right. But I'm going to work through it one way that I think is going to help us when we get to the composition part. So you're going to take the $80 and subtract 25% of $80. Okay, I'll let you kind of think that through. It might have been a long time since you've done some percents, so we're going to take this fairly slowly here with the percents, just so we can refresh your mind on that memory. Percent, like the word literally means per or out of 100. So the word cent, C-E-N-T, like that suffix, or it could be a prefix, means 100. So if you think how many cents are in a dollar, 100 pennies are in a dollar. How many years are in a century? That would be 100 years. And so C-E-N-T, like literally means 100. In fact, like the French word for 100 is cent. And then your per literally means out of. So when you see 25%, what that actually physically means is 25 out of 100. Like that is what the word means. Of is often used in place of multiplication. And then I don't really like using the fraction here. So 25 out of 100 is 0.25. So what I've done there is I've just kind of reasoned our way through the percent there. So percent means out of 100, which means like whatever your percentage is like over 100. That's how you get the denominator, per 100, 25%, 25 per 100. And then I prefer to use the decimal. You're welcome to use the fraction if you want. So in order to figure this out, we would do 80 minus 25% or 0.25 of 80. That's going to be 20. And 80 minus 20 is 60. And so the final answer to that problem is $60. So you're going to walk out of the store with a $90 pair of jeans for $60. Now, my one pair of jeans that I've owned that have been that expensive, I think I had like 3 discounts on them. Like I had a gift card, and then they were on sale, and then I don't remember what else, but I did not pay $100 for them. That much I'm sure of. So anyway, we've got the process here. Now, if you only had to, well, let's go through and do the composition. Okay. So the composition for this, suppose you didn't know that the original pair was $90. Suppose it was like, what kind of discount would you have there? You could do it this way. Hang on, let me. Aha, I got that. I did that right. Okay, I just duplicated the ink, the page, but not the ink. Yay. We figured this out. So suppose you have a pair of jeans and they're like just price P. Okay, so the first thing you would do is you would subtract the $10. Now, when you go to the register, they're going to take 25% off. I should probably not do a horizontal line. So in the original problem, we took the discounted price and then we subtracted 25% of the discounted price. Except now I don't actually know what that number is. I have an algebraic expression instead. I have this P minus N. So over here, and notice I'm using a strategy here. I'm using a problem that's fully numbers to help me reason my way through a problem that has some variables in it. So there's actually a strategy here. So we've got 80 minus 25% of 80. Well, I don't have 80, I have P minus 10. So I'm going to do P minus 10 minus 25%. I'm going to jump to the 0.25% of P minus 10. If you look back on the previous page, it's pretty much the same thing, only instead of 80, I have P minus 10, because I don't know what my price is. So P minus 10 minus 25% of P minus 10. And then we'll just do some simplification here. So this would be 0.25p, and then we're going to do a negative. We're going to distribute the decimal through. So a negative times a negative is going to give us a positive, and then that we would move our decimal point over. So we're going to have plus 0.25 on that. Now we've got some like terms. So I have 1p minus 0.25p, which would give me 0.75p. And then I've got negative 10 plus 0.25, which is negative 7.5. Now, there's my function. Now, what I want you to notice there is what we've done is composition. So this is actually composition, where we took one function and plugged it into another function. We took the discount with the $10 and we plugged it into the 25% discount function. That's what we did there. Now, take your price of $60 or $90. So we do 0.95 or 75 times 90 minus 7.5, and this ends up being, I did this out like, it's like 67.50 minus the 7.5, which gives you $60. So now I'll give you kind of a chance to think that through. This way is just doing it one time with just the numbers. Here's the price of the jeans. Here's the price when you get to the register. You actually swipe your credit card. This one is using composition. So we're actually taking one function, we're taking the $10 discount, and we're plugging the $10 discount into the 25% discount. And we're doing composition of functions, and we're coming up with this new function. And when we plug in the 90, we get the same number out as we did when we just did it with straight numbers. So a lot of you are probably saying to yourself, Miss Taylor, I understood the first way. It was clear, it was straightforward. It only took us 1, 2, 3, 4, 5, 6 steps, and that was with you doing a lot of extra stuff with that percent stuff in there. We could have done it in like 3 steps or 4 steps. This was confusing. We had peas floating around in there, and you were putting peas in, and like I don't even see how that was composition. Okay, like I don't know, and we ended up with the same answer, and it just seems like that's a lot more work to get to the same answer, and maybe we've overcomplicated the problem. So here's the question I'm going to pose to you guys. Here's the question. When would it be worth it to do the composition? Or, phrased another way, when would it be worth it to come up with a single formula that does both discounts at once instead of calculating the discount separately? So I'm going to go back and we'll look at these one more time. In this first example, we actually did the discounts separately. Here's the first calculation for the first discount, and then we had to do a separate calculation for the second discount. And so we have two calculations there. In the second strategy, we do this work and we develop one formula for both discounts. And so when we plug in the 90, we only plug it into one formula and we do one discount, as opposed to doing two separate discounts. But we had to do some legwork to get to that formula. Like we had to do some thinking and some plugging in. Basically, we had to do the composition to get to the formula. Once we have the formula, now we've got a shortcut that does both of the discounts at once. We don't go through the $80. The $80 is gone from the problem. We go straight from 90 to 60. Here we have to bridge into the 80 and bring the 80 through. So when is it worth it to come up with a single formula that does both discounts at once instead of calculating the discount separately? I'm going to pause the video and I'm going to let you guys think about it. Sometimes I'll have classes that will come up with a good reason why you would want to do this. Other times, my classes kind of come up dry and I have to help you a little bit. So we'll pause the video and then we'll talk about it together. All right, and here's what we got. The answer to that is when you have to do repeated calculations. So if you're just doing one pair of jeans, so while doing the composition is really not worth it for one pair of jeans. If you're just going to go into the store, you're going to buy one pair of jeans, then you're probably better off just doing the two separate calculations. It's not a big deal. It's not a lot of work. But if you were to have many items, okay, it would save you time to do the composition, because once you did that work once, now all the rest of the calculations would go faster. So suppose I said, all right, not just the 90 pair of jeans. I want you to find the discount for something that was $150, something that was $80, something that was $10. Something that was $35, something that was $47.50, okay? If you're doing this calculation separately, you're going to have to do two calculations, two calculations, two calculations, two calculations. If you do the composition, you're going to have to do two calculations for the first one because you're going to have to come up with the formula and then plug it. Whoops. Okay. I messed that up. You're going to come up with the formula and then you're going to have to plug it in. But once you have the formula, you will only be doing one calculation. And so eventually, the more items that you have, you will eventually save time by doing that composition and coming up with that one function that merges the two functions together. So I hope that at least sort of addresses the question that you might have, is like why composition is a thing. When you plug one function into another function, what you create is this new function that actually does the job of both of the original functions. So it could be both discounts. If you're only doing one item, no, it's not worth it. It is a lot of extra work. But if you've got to do lots of items, then that composition, that extra work in that first step to come up with that hybrid function that does the work of both will eventually save you time. So I don't know what we're going to do for the rest of the classwork today because I have no idea at the time that I'm recording this, but it'll be fantastic and it's going to be so much fun. And we'll just head into that next.